house here in Westerly, Rhode Island. For the past 70 years, our little ranch here stood just 1 story tall. But over the next couple days, it is going to sprout a 2nd level. Now, over the past couple weeks, there's been a lot of demolition. The exterior walls were taken down on this side of the house. A 20-foot tall brick chimney came down with the help of Mark McCullough. And now, Jeff, we have framed up the perimeter walls for the 1st story. Time to start thinking about the 2nd story. And man, you promised us a big beam. Looks like you delivered. What am I looking at here?
You're looking at one single piece, 7-inch by 18-inch
We got
PSL.
And a PSL being?
Parallel strand lumber. So you can see here all these strands of lumber that are in parallel, all pressed together in a resin.
Yep.
And it adds a considerable amount of strength.
And so last week you said, what, 40 feet long? Is that right? And that's because this is just a big wide open floor plan.
Pretty much. There's one post in the middle here. It goes into that wall pocket there. We got a post on the other end. And it's an open floor plan, back and forth here.
So this is going to help carry our new 2nd story. Any sense of how much weight that is?
We got about 35,000 pounds of floor system loading onto this, either side of this beam.
So we need a big beam. If we weren't using a PSL, I presume, what, steel's your option?
Steel, yeah.
What do you think about that?
Well, we would have to have a steel column, and then crane, and then we'd have to pack out that steel web so that we can, with wood, so that we get our floor system attached to it.
Whereas with this, you're just going to put, what, the hangers right to it?
Yeah, nail right into it.
So how much of this is going to be buried in our floor system?
So our floor system's 14-inch.
So
we've got 4 inches of exposed there, and that's going to get buried in transition. So we've got an archway into this living room, and then we got a coffered ceiling designed into that living, the kitchen dining room, and that disguises that.
So you said 1 post in the middle. How do you hang the ends?
So this end is going to go into a wall post there. There'll be another post supporting it, and then we're just framing this wall up. It's going to stand up, and we're going to post onto that one.
So we got to put that up before we put this up?
We're going to put that little section of wall up, and then we're ready to go. Ready? Ready? All right, that post is set. So the beam on wheels here, we're going to slide it over. We'll come right up against that column, and we'll jack it up. And then once we get up to a certain height, we'll go in to that pocket, and then we'll swing onto the top of this.
Come up.
Jeff, you're there. Oh.
Yep, good. Got it? That is beautiful, Jeff.
How about that? 1 piece.
40 feet clear span. That's awesome.
We got a column going right here, and we're ready to set floor joists.
All right, beauty.
That's
progress. These windows are the only source of natural light down here in the basement. But we're going to be building a deck off the back of the house, and that's going to cut all the sunlight off. So Jeff has got a noisy solution for us. So Jeff, what do you got for us for a solution?
So the other side, obviously, we've got that deck, so that's getting darkened. So what we're going to do is we're going to saw cut an opening in the foundation on the front side. There'll be a walkway that'll go by it, and we'll create a window well so that we retain the earth. But we've lined up a window to match these 2 windows that are in that front mudroom.
So the grade that I'm seeing right here is basically the finished grade? Is that roughly the height?
Yeah, that'll carry right across here.
Hence the window well.
Yep.
Is it necessary? Is this for code or aesthetics or what?
You're supposed to have 2 operable basement windows per code. And obviously the other windows will remain there, but they really aren't going to allow for much daylight. So it's really more of a daylight convenience than it is anything else.
All right, well, I'm dying to find out what Bill's going to be doing for us. So let me check. Hey, Bill, how you doing?
Good morning.
I'm coming into your hole, okay? So, good morning. What is your process for cutting this hole here?
Okay, so essentially we're going to cut out the concrete with a giant skill saw.
Yep.
With a big blade cutting through. So the first step is you determine where the window is going to be, you mark your lines, and you set anchors.
Beautiful.
These anchors hold this type of plate that'll rotate on a cam that'll give you an adjustment to where the track has to go. I've already done that here, right? This is all set to the cut line, which is right here.
Okay.
Okay?
And the track is going to be holding what?
The track will hold this part of the saw, which is called the carriage.
Yep.
Right? This carriage mounts on here. It runs on rollers that run it back and forth, and a cog gear that lets it move back and forth. I'll run the saw back and forth with a drill with the gear.
And obviously the blades are right here. What do you got for a blade?
Okay, so this is a diamond blade.
Yep.
Right? There's diamonds inside each one of these segments, right? The exposed diamonds, the rotation cuts the concrete.
How many cuts do you get out of a blade like this?
A blade like this, you probably get 40 or 50 cuts. And what determines how long it lasts is the aggregate in the concrete and the amount of rebar in the concrete.
Okay. And in terms of safety for you, what are you doing to keep the dust down, to stop the chips coming out? What's your process?
To keep the dust down, everything we use is with water. We pump water from the truck. It goes through the saw. It serves a dual purpose. It cools the motor, lubricates the blade, and keeps the dust down.
Got it. Okay.
It runs through a conversion box that takes it from 60 hertz, which is typical electric, converts it to 400 hertz.
Whoa.
So it essentially boosts the power 7 times.
You gotta get me one of those.
Yeah.
Didn't know they even existed.
We've got 8.5 inches here with this blade, which is a 24-inch blade. We're going to switch this one out and go to a 30. Should get us through the 10.5 we need.
Okay. So the second blade did a trick, right? Went all the way through.
Yep.
Now you got to go to vertical.
Right.
So close. Oh, look at that.
Hey, Bill.
Bill, you're the man. That's awesome. So what do you got next, Jeff?
So we got a double pressure treated frame going all the way around. One down the middle to line up with that mullion, and we got 2 new windows going in.
Love it. That's awesome. Jeff and his team are big fans of the laminated strand lumber they're using for the framing. They like it for its strength and consistency. So we decided to see how it's made. To find out, we traveled about 100 miles north of the U.S. border to Ontario, Canada. This is Kenora, a small town that makes a lot of strand lumber. Bill, nice to see you.
Nice to see you.
I can tell from what I'm looking at here, this is already a very big operation. You're the plant manager.
That's correct,
You
yes.
got a big deal going on here.
Yeah. So this is where it all starts, Kevin. This is poplar logs arriving about 8 feet long. About 50 of these trucks a day arrive on site to keep us going.
Unbelievable.
Yeah, it gets downpiled in the yard over there. You know, we've got about 4 or 5 weeks supply, but this is where it all starts, coming from the bush.
And the whole purpose of everything going on here is to make some LSL, laminated strand lumber, right?
That's correct. That's what we make here.
All right, well, you ready to show me the whole process?
You bet I am.
All right, thank you.
So Kevin, this is the start of our process here. So these are the 8-foot poplar logs that are being loaded into the process. We call those magazines. So we've got this high lift loader that takes the logs either from a logging truck or actually from our yard and loads them into those magazines. So then it's really the weight of those the logs in those magazines that push down into the conditioning ponds. So this is really the start of our whole LSL process. So this is the conditioning ponds and jack ladders. So the logs spend about 8 hours in the conditioning ponds. The ponds are heated up very hot, like 130 degrees during the winter, and it's really critical to thaw out the wood.
So primarily to thaw the wood and make it a little softer?
That's correct. During the winter, even during the summer, we'll have a little bit of heat on the ponds, you know, just to soften it up a little bit.
Big giant pond full of water. Machine brings them up here, and where's it dropping it?
Dropping it into a jack ladder outfeed conveyor, and that conveyor is going to feed the logs into debarkers a little bit down the stream. The logs also go through a metal detect conveyor, the gray thing right there.
Yeah.
So we really want to prevent any metal getting into our debarker or into our stranders. So Kevin, we need to remove the bark from the logs. So we have each of the logs go through the debarker singularly. And we've got 5 knives that rotate around the log and cut the bark off. Then the barks are ready for the next part of the process, which is stranding. So we've created a pocket of wood here, and that's going to get pushed forward into the strander ring. The strander ring is about 8 feet in diameter or so. It's got 48 knives around the interior of the ring, and it'll travel through the wood and cut the strand.
So that big ring there, that's the actual strander, and it's going sideways across the wood?
That's correct. It's driven by a 1100 horsepower motor. And then it'll get indexed ahead for another cut. We're producing strands that drop off the bottom of that strander and go up the incline conveyor to some storage bins. This is one of 4 dryers that we have. The strands travel through here. They're being tumbled around like in a clothes dryer. And so they travel through to the end of the dryer. It takes about 15 minutes or so at about 1,000 degrees Fahrenheit to get down to the 2 to 3% moisture content that we need.
And what's the heat source for your dryer?
This is really the heart of the plant, Kevin. This is our one of our 2 fluidized bed combustors. Contains about 8 tons of sand, and we start it up with natural gas, get it all heated up, and then we add fuel made up of our bark that we pick off the logs and off of sander dust or sawdust that we generate in the plant. So all the residuals that we generate essentially get burnt in our combustor.
Right.
We're producing flue gas off our combustor to dry our strands down to 2 to 3% moisture content, and then we're also using the flue gas to heat up thermal oil. When the plant was built, it was one of the largest thermal oil systems in North America with 80,000 gallons of thermal oil. And we use that thermal oil to really move heat around the plant. We use it to heat up the ponds, conditioning ponds. We use it to keep the plant warm during the winter. We use it to generate steam for our steam injection press.
Wow. So very, very efficient, no waste.
No waste at all. And this is the control room. This is where we manage and operate our energy system and our dryers in this area here. Mm-hmm. And over here we operate our blending, where we're blending strands with resin and wax. We're forming a mat through orienters to line up the strands in the machine direction. And that's outside here. And then we have a mat. Today we're pressing 1.5-inch wall framing products.
So essentially 2x4s that we use.
That's correct, yeah. The mat of strands is about a foot thick coming down the line. The forming process is a continuous one, so we have to cut that mat at some point. And we have a flying cutoff saw that starts to travel with the mat and cuts across. Then we accelerate the mat into the single opening steam injection press, which is very unique.
And how long is the mat, the one that you cut?
The mat's about 64 feet long.
Wow.
8 feet wide, and again about 12 inches thick for this product. Mm-hmm. It goes through the pressing process and a very unique steam injection press, which softens the mat with steam and helps cure the resin. After the mat then becomes, we call it a billet, and it'll actually go through a splitter saw that'll split the billet in half, 4 foot, 4 foot, for example, and goes down a roll case into a billet cooler. We need to cool it off for a couple hours so that it stops off-gassing.
Can you cut them once they're cooled?
That's correct. Then we'll go to our products area, which is really just a sawmill that cuts the billet down to size. We make something like 500 different products out of timber strand, out of LSL. This represents the kind of range from a 2x4 wall framing material, all the way to this 3.5-inch by 11/7/8-inch header that's used above garage doors and above walls and windows.
And everything in between.
And everything in between, yes.
Hey, Dan.
Hi, Kevin. Welcome to our QA lab.
Thank you. What are we testing?
So today we're going to be determining the strength and stiffness performance of this 155 3.5-inch beam. So basically what we're going to do is we're going to take this beam and we're going to put it on this test frame. We're going to load it to a certain deflection. From that data we receive back from this test frame, we'll be able to determine its stiffness and strength performance and whether or not it met the required performance for this grade of product.
All right. That was a full-on explosion.
Yeah, that was a good test.
So it broke. What'd you learn?
So what we learned was it took over 4,000 pounds of force to break it. And the data is also telling me that it met its stiffness requirements or its MOE requirements. So we got a good test. Typically in the lab, we'll do 4 more of those samples on the flexure machine. And then over there, we're going to actually rip some boards in half on our tension tester.
Let's do that.
Okay. Okay, Kevin, what we're going to do here is we're going to determine tensile strength of this product. We'll turn the machine on and it'll basically just rip it in half.
So what am I looking at here? What are the different metrics?
So what this is telling us is basically the amount of load or pounds force it has on that tension.
Climbing fast.
Climbing fast, and it should break approximately over 30,000 pounds to actually bring it to failure.
30,000.
That's it.
That's unbelievable.
So that broke at over 35,000 pounds.
Wow. And so what would be a passing number? What's the threshold?
For this one, for this particular product, if you're above 20,000, you're in good shape.
So you're well above.
Oh yeah, we're well
Pass
above.
with flying colors?
Yeah, we're well above. That was a good test.
Congrats.
Okay.
So this is our automatic strapper where we're applying vinyl straps around the stack, every 4 or 5 feet or so to hold the stack together.
Right.
And then it gets transferred over to our bundle cut saw over here, which is really a horizontal bandsaw. And that's what we use to finally cut the 64-foot stack to lengths the customers want.
So you've actually banded it while it's still 64 feet long.
That's correct, and we automatically know where the cuts are going to take place so we can position the band. We now have bundles of LSL that are cut to length, and they're approaching our wrap station here. So at our wrap station, we're applying an end seal, a waterproofing end seal. We're applying waterproof wrap to our bundles. We're stapling it on. And then we're applying SAP logos and product information onto the bundle. And this is where the bulk of the people in the plant work is actually at the wrap station.
Everything else is automated.
That's correct. Haven't automated this yet, we're working on it. This is our railcar loading bay here. We'll load out up to 25 railcar a week and about another 75 trucks, and that's going to locations all across North America. In fact, we also ship some off to Japan.
Well, that is a lot of product. Bill, I really appreciate the tour, and I know we've got more of this coming to our house, so I'm thanking you in advance for that delivery as well.
Thanks very much.
Appreciate it.
So Jeff, you're making good progress here. You got the second gable being framed right here.
Yeah,
Looking good. That one over there is already ensheathed and ready to go up.
you bet.
I see these studs are gonna run right from the plate all the way up. So it's almost like a balloon framed wall.
Right, and the nice thing about the engineered studs, to your point, we can balloon frame. We've got a 20-footer here right to the peak, so
Yeah.
that thing's straight as an arrow.
It's
really
good when
works
you
out
balloon
well.
frame because you don't have any of that hinge effect where the
Exactly.
two plates meet.
Exactly.
So
Yeah.
it's actually a pretty strong wall.
Yeah.
But these suckers are heavy.
They are heavy. Yeah.
All right, so let me give you a hand. We'll
All
shoot
right.
this down.
Okay. Everything's perfectly flush. All right, so we have to blow off this deck to put our weather membrane down.
Right, now this is a self-sealing membrane that's gonna skin right over the deck and stick to it. So you're right, we wanna make sure it's clear. And this is designed to keep water and air from penetrating the siding. It actually allows the house to breathe. Using a hard rubber roller to push the product tight against the sheathing to make a good connection.
right, all ready to go. Now we're ready to stand it. We're gonna need some help.
Yeah, we definitely need some help.
All right, I'll get the guys up here.
All right, good.
All right, so I need 24-inch rips of OSB.
All right, so when you're building a wall that you're going to stand up on the floor, the first thing you want to do is stand this plate up in the position that it belongs. So there's a line snapped on the deck right back here, and the edge of it is on that line. You then attach all your studs. To make sure when you stand this wall up that the wall doesn't slide off, you apply this piece of metal strap right here, and there's about 4 of them on this wall. One here nailed on the side, goes down underneath, and it comes out the